Hello and welcome to my channel. In this video we are going to learn how to differentiate or find the derivatives of some trigonometric functions. So let us start with the first one. The first function is f of x is equal to tan x. So here we have to find the derivative or differentiate tan x with respect to x. Now we have an identity that relates tan to sin and cos, which is tan x is equal to sin x over cos x. So here we have rewritten f of x as, in place of tan x we have written sin x over cos x. Now this is of the form u over v. So here to differentiate tan x we are going to make use of quotient rule of differentiation. Now the quotient rule we can apply for u over v is d by dx of u over v is equal to v times du by dx, that is once we are going to differentiate u, minus u times dv by dx, that is we are going to differentiate v next, over the denominator squared, that is we have v square over here. Now since we have considered sin x as u and cos x as v, we have written here u is equal to sin x and v is equal to cos x. Now since in the formula we can see we have to differentiate u and we have to differentiate v, we have differentiated u, that is du by dx equal to, now remember that the differentiation of sin x is always going to be cos x. So this is one of the formulas of differentiation of trigonometric functions that you have to remember. So differentiation of sin x is cos x. And the differentiation of cos x is always going to be minus sin x. So this is the first basic differentiation formula you have to remember, and this is the second one. Now once we have got this, we are going to just plug in these values in this formula. So we get differentiation of fx with respect to x, that is dfx over dx, is equal to, and in place of v we have written cos x times du by dx, which is cos x. So cos x times cos x minus u times dv by dx becomes sin x times minus sin x over, now v square becomes cos x the whole square. Now simplifying this we get cos x times cos x is cos square x, and minus times minus gives us plus, and sin x times sin x gives us sin square x. So this second term becomes plus sin square x over, now cos x the whole square can be also written as cos square x. Now cos square x plus sin square x is another trigonometric identity, which is cos square x plus sin square x is always equal to 1. So our numerator goes down to 1. So here we have written 1 over cos square x. Now another trigonometric ratio, that is secant, is the reciprocal function of cos x. So since here we have got 1 over cos square x, we can write it in terms of its reciprocal function, that is secant square x. So this is the differentiation of tan x which we get with respect to x. Now let us move on to the next question. Find the derivative of sin square x. Now we can also write sin square x as sin x the whole square. They both are same. Now to find the derivative of sin x the whole square, I am going to make use of the chain rule. So I have explained chain rule, power rule, quotient rule, product rule, and all the rules of differentiation in this playlist. And I will also drop down the link in the description box below. So if you want to refer it before going through this video, you can give it a try. Now let us start with the chain rule. Now whenever we are using the chain rule, there are 3 basic steps to be remembered. So the step number 1 is differentiating the outside. So here basically we are going to take the power, and using the power rule we are going to differentiate sin x the whole square. So according to the power rule, the differentiation of x to the power of n becomes, now the power jumps down, so we get n times, and the x power reduces by 1. Similarly, if you see here in the step 1, that is differentiating the outside, we have taken this power down, that is 2 jumps down, and it multiplies with sin x, and the power of sin x has reduced by 1. This is being done by using the power rule. Now simplifying this, we get 2 times sin x 2 minus 1 to the power of 1. So you do not have to write the power of 1. So this is the first step. Now the second step is differentiating the inside. So differentiating the inside means whatever term is there inside the bracket now needs to be differentiated. And in the previous question we have seen that the differentiation of sin x will be always cos x. So here we have written the differentiation of sin x as cosine x. Now once we have got the step number 2, let us move on to the last step, which is multiply both the terms got in step number 1 and step number 2. So in step number 1 we got 2 times sin x. Now we are going to multiply it with the term got in second step, that is cos x. So here the differentiation of sin square x gives us 2 sin x cos x. This is going to be our answer. Now let us move on to the third question. Y is equal to sin 2x times cos 3x. Now here we have a combination of two different functions. That is sin 2x is the first function and cos 3x is the second function. And there is product between these two functions. So to differentiate y with respect to x, we are going to make use of product rule. So the product rule is given as d by dx of u times v, where u is the first function and v is the second function, is equal to u times dv by dx plus v times du by dx. Now here we have considered the first function, that is sin 2x as u and cos 3x as v. You can also consider sin 2x as v and cos 3x as u. It will give you the same correct answer. So here the next step is, since we can see in the formula we need to differentiate u and v with respect to x. So we have started with the differentiation of u, that is du by dx is equal to, now to find the derivative of sin 2x, we need to make use of the chain rule over here, because we can see 2x is enclosed within the function sin. So basically we are going to make use of the three steps again, that is differentiating the outside. Since there is no power over here, we are going to consider this as one complete function, and this is going to be the outside. So the differentiation of sin 2x gives us cos 2x, because the differentiation of sin is cos. And then we are going to differentiate the inside term, that is 2x. So the differentiation of 2x is 2. Then the step number 3, that is multiplication of term got in step number 1 and step number 2. So du by dx gives us 2 times cos 2x. So for v is equal to cos 3x, again we are going to make use of chain rule, where the cos behaves as the outside function. So the differentiation of cos x is minus sin x. So cos 3x becomes minus sin 3x. And now the step number 2, where we are going to differentiate the inside term, which is 3x. And the differentiation of 3x gives us 3. And step number 3 is multiplication of the terms got in step number 1 and step number 2. That is minus sin 3x times 3. So simplifying this, we get dv by dx as minus times 3 is minus 3 times sin 3x. Now once we have got all the terms, we are just going to plug in these values in this formula. So we get, now dy by dx is equal to u times dv by dx gives us, now u is sin 2x times dv by dx is minus 3 sin 3x plus, now v times du by dx gives us cos 3x times 2 cos 2x. Now simplifying this, we get dy by dx is equal to, now all these three terms gets multiplied, giving us minus 3 times sin 2x times sin 3x plus, now these three terms gets multiplied, giving us 2 times cos 2x times cos 3x. So this is the differentiation of the given function. Now let us move on to the next question. F of t is equal to e to the power of t over sin t. So here basically we have a function that includes the exponential function, that is e. And this is of the form u over v. So we are going to make use of the quotient rule here to differentiate f of t with respect to t. So here we have considered the fraction as u over v. And since we are going to use the quotient rule, I have written the formula over here. Now u is equal to e to the power of t and v is equal to sin t. Now the differentiation of u, that is e to the power of t, is going to be e to the power of t itself. So du by dt will be equal to e to the power of t. V is equal to sin t and the differentiation of sin is going to be cos. So we get dv by dt is equal to cos t. Now let us plug in all these values in this formula. So we get differentiation of f of t with respect to t is equal to v times du by dx gives us sin t times e to the power of t minus u times dv by dx gives us e to the power of t times cos t over v square gives us sin t the whole square. Now we can see that e to the power of t and e to the power of t is a common factor. So we have pulled it out and it gets multiplied with the remaining terms, that is sin t minus cos t over sine t the whole square can be written as sine square t. So this is the answer, or this is the derivative of the given function f of t. Now let us move on to the next question. G of x is equal to cosine of 3x square plus 4x plus 5. Now to differentiate this, we are going to make use of the chain rule. So the step number 1 is differentiating the outside. Now since there is no common power for this given function, the cos is going to act as the outside function, and we know that the differentiation of cos is going to be minus sine. So here we get the differentiation of the outside term as minus sine of 3x square plus 4x plus 5. Now moving on to the step number 2, that is differentiating the inside term. That is, we are going to differentiate the terms which are inside the bracket, and to differentiate this we are going to make use of the power rule. So here differentiating 3x square we get 3 times. Now power comes down, that is 2 comes out and gets multiplied with x, and the power of x reduces by 1, that is the power 2 becomes the power 1, that is by using the power rule. So the differentiation of first term becomes 3 times 2, which is 6, so 6x. Now differentiating the second term, the differentiation of 4x is going to be 4, and 5 is a constant, and differentiation of a constant is 0. So here the differentiation of the inside becomes 6x plus 4. Now moving on to step number 3. So step number 3 is multiplying the terms got in step number 1 and step number 2. That is minus sine of 3x square plus 4x plus 5 gets multiplied with 6x plus 4. So here simplifying it we get g dash of x, or differentiation of gx with respect to x. The minus multiplies with 6x plus 4, giving us minus 6x plus 4 times sine 3x square plus 4x plus 5. So this is going to be the differentiation or derivative of the given function. Now moving on to the last question. G of x is equal to secant of x. Now we can write secant of x as 1 over cosine x. Now to solve this, I'll be showing you 2 methods. The first one is by using the quotient rule. So here we have written g of x is equal to secant of x, which can also be written as 1 over cosine x, and this is of the form u over v. So using the quotient rule, we have considered u as 1 and v as cos x. Now the differentiation of u, that is du by dx, is equal to, since 1 is a constant, it is going to be 0, and the differentiation of v, that is dv by dx, is equal to minus sine x. Now once we have got all the values, we are just going to plug in this formula. So we get differentiation of g of x with respect to x is equal to v times du by dx gives us cos x times 0 minus u times dv by dx gives us 1 times negative sine x over v square becomes cos x the whole square. Now simplifying the numerator, cos x multiplies with 0, so this term goes down to 0, and negative 1 multiplies with negative sine x giving us positive sine x over cos x the whole square can be written as cos square x. So differentiation of secant x becomes sin x over cos square x. So this was the method 1 where we had used the quotient rule. Now let us look at the method 2. So in the method 2 we are going to make use of power rule and chain rule. So before that we are going to take this cos x to the numerator. So we get cos x to the power of negative 1. This is done by using the laws of indices. Now once we have got it in this format, we are going to begin with the chain rule. That is, we are going to use the 3 steps. Step number 1 is differentiating the outside. So here we have a power, that is negative 1. So using the power rule, the power jumps down, that is negative 1 comes outside and it gets multiplied with cos x, and the power of cos x reduces by 1, giving us the power as negative 2. So this was the differentiation of the outside term. Now the differentiation of the inside term, which is cos x, and the differentiation of cos x is minus sin x. And the step number 3 is multiplication of step number 1 and step number 2. So here we get negative of negative sin x gives us positive sin x, and at the same time we have taken cos x to the power of negative 2. Since the power is negative, we have taken it to the denominator and the power has become positive. So cos x to the power of negative 2 has become cos square x in the denominator. So if you see, the answer we have got in method 1 is same as the answer got in method 2. So these are the 2 methods which you can use and whichever you are comfortable with. Either you can use the quotient rule or the chain rule to differentiate the given function. That was secant x. So this is going to be our answer. I hope you have understood all the steps and liked the video. And if you found this video useful, then check out this playlist where you'll find more examples of this kind. And if you're liking my videos, like, share and subscribe to my channel. And thank you for watching.